This is the fifth and final part in this SMC Familiarization series. I'm Rob Holcomb, Engineer and Product Manager at IDI. We'll wrap things up with a review of what we've covered and look ahead to what next steps might look like for someone interested in getting started with SMC design or molding. We opened with an explanation of what sheet molding compound is, what it looks like, and how it's used. We had a look at some examples of SMC products. Hopefully it's clear how broadly SMC can be used and why it's gaining popularity. Though most design life cycles follow a common arc, every part will have its own set of challenges and opportunities throughout the value stream, and IDI is equipped to support that. We went on to detail how SMC is compounded and delivered, then how it's used in the compression molding process. Finally, we took a brief dive into finishing processes for SMC components before they're shipped to the next customer in the chain. Whether you're designing a part and choosing a material as an OEM, or you're an established manufacturer looking to expand capabilities into SMC, or perhaps even a Tier 1 design partner somewhere in the middle, it will be beneficial to have a high-level understanding of what it takes to produce an SMC part. Here, we present a simplistic approach and a more advanced approach, and acknowledge that reality will be some blend of these two to meet production requirements. In the simplest case, SMC molding begins with temperature-controlled storage to maintain SMC shelf life. SMC charges are cut to size and weight using a slitting table and scale. The compression mold, of course, heated by whatever method is most convenient to your operation. The mold sits in the press. These are typically hydraulic and denominated in hundreds of tons. The press is sized to meet the pressure needs of your particular part size and shape. The press controls operate the opening and closing, pressure, and temperature of molding. The heat source may be electric cartridge heaters, which may require a transformer, steam requiring a boiler, or oil requiring a recirculating oil heater. High-pressure, closed-loop water heaters are also gaining market share. The molded part will be ejected and deflashed, likely in a cooling fixture, then moved on to the next process. Opportunities to advance the process include cold room storage, closer to 4 Celsius or 40 Fahrenheit, to further extend SMC's useful life. The slitting and peeling operation plus weighout can be programmed into an auto slitter. Robotics and end-of-arm tooling are capable of automating the charge stack-up, placement in the tool, removal from the tool, and even cutting and deflashing. Advanced press controls include self-leveling, multi-stage programmable pressure profiles, and in-mold sensors. Vacuum can be designed into the tool to pull away the air and any outgassing as the part fills out and begins to cure. Vacuum requires vacuum lines, a pump, and a vacuum tank. Lastly, a post-bake oven or continuous post-bake line can optimize tack time. This concludes the 5-part series SMC Familiarization. My hope is that this has been informative and clarified what SMC is and how it's used. Let this series be the beginning of a conversation about the value that SMC can deliver. IDI stands behind its commitment to the industry. We collaborate regularly with partners at all stages of the value stream to deliver creative and meaningful results. This has been Rob Holcomb, Engineer and Product Manager with IDI, asking, how can we help you deliver meaningful results. Thank you.